Up until now, we've talked about marking the methods as async, introducing the await keyword, and the fact that the asynchronous operations introduce a separate thread where the work is being done. This avoids locking up the UI thread or the main thread of the application. This might seem like magic, and you're probably wondering now what the await really does and how it affects the flow of the code. As you discovered in the previous clip, introducing the await keyword allows you to retrieve the result from an asynchronous operation when that result is available. What it also does is to make sure that there were no exceptions or problems with the task that's being awaited. Therefore, it's a way to get the result, as well as validate that asynchronous operation. What the await keyword also does is introducing something called a continuation. The continuation is what will be executed after the asynchronous operation, meaning the code after the await keyword. This code will run once the task has completed, and it will run on the same thread that spawned the asynchronous operation, which in our case is the UI thread. This can be configured, but we'll get to that later. In our case, we perform an asynchronous operation to go ahead and retrieve some stock information. As we have the await keyword in front of the task that represents this asynchronous operation, all of the code after the await will be executed in what's called a continuation. You're not limited to just one continuation. In fact, it's pretty common that a method may contain more than one await. We saw this earlier when using the HTTP client. Each await in its turn introduces a continuation for the code after it. You can have as many awaits as you want inside your method marked with the async keyword. They will all introduce a continuation, which allows you to make sure that the code after the await keyword is only executed once the asynchronous operation that you are awaiting completed and did so successfully. If getStockPrices can't find the stock we're searching for, it will throw an exception. We only want to update the UI with a list of stock prices if they could be loaded. If they couldn't, we'd like to give the user a hint that something went wrong. We can wrap the code in a try block and catch any exceptions that could occur. The await keyword will validate that the operation completed successfully. But if we search for a stock that doesn't exist, the task it's awaiting will be marked as faulted. What happens when the await keyword sees that the task faulted with an exception, it'll throw that back to the current thread. This means you'd end up in a catch block, and you could give the user a note of what's happening. We can run the application and see that if we search for a stock that doesn't exist, we'll get an error in the notes section of the application that tells us that there was an error. In this code block, the code that would update the UI with the list of stock prices and the code inside the catch block are both in the continuation of the asynchronous operation and will be executed on the UI thread. The await keyword ensures that we are back on the original context, which in this case is the UI thread. Every time I refer to the original context, I refer to the UI thread, or the thread that started the asynchronous operation. Just as we were updating the data grid when we were asynchronously getting stock data, we can interact with notes.txt to update it with an appropriate error message. This shows how the continuation allows for work to happen on the original context that spawned the asynchronous operation. If you've ever done multi-threaded programming in UI applications before, you know that updating the UI from different threads isn't allowed. Therefore, it's so important to know that the default behavior when using await is that you will be back on the original thread in the continuation. We now understand that after the await keyword, we're inside something called a continuation. And when using the await keyword, the continuation allows you to perform work on the original context. This means that we don't have to worry about working across different threads. It makes our lives a whole lot easier. Not only does the await keyword allow you to retrieve the result from an asynchronous operation, it is also for validation to make sure there were no problems. It validates the task by checking if there were any exceptions. Comparing this to other approaches that you might have seen in the past, this makes it a whole lot cleaner, easier to maintain, and ultimately provides a better user experience. So far, we've used pre-existing asynchronous methods. But what about if we'd like to introduce our own? Continue to the next clip to learn about that.